Okay, so an example of number 4, I'm going to go ahead and just do 4a. So it says calculate the mass of a given element in each of the following quantities. Oxygen in 4 grams of manganese dioxide. So I'm calculating the amount of oxygen given 4 grams of MnO2, so manganese dioxide. Let's start with doing basically a percent composition. What we need to find out is what the percentage of oxygen in this compound, and then we can apply that percentage to the 4 grams. So I'm going to start with a percent composition formula. So manganese, I need the individual mass of manganese, which is 54.94 according to the periodic table on this slide. If you're using a different periodic table, you should be using all of the mass numbers available to you. Oxygen, I need to multiply it by 2 because I have 2 of them, and on here it is 16.00, so again I'm going to multiply that by 2. This stays 54.94 because it is just multiplied by 1, and 16.00 times 2 becomes 32.00. So now I'm going to add those together, and I get 86.94. So my question, I don't really need to do percent composition for everything. It's only asking me for oxygen, so I'm just going to find the percent of oxygen. So that's 32 grams divided by, this is an add over here, that was just like equal. I don't want you guys to get confused. Divided by 86.94. You can times it by 100 to get a percent. We are going to take it out of the percent later, so if you don't want to do that, that's okay. But if you're just trying to follow the formula, when you put that into a calculator, you should get 36.81%. Now, that's the percent of oxygen in the compound. So I need to know what is 36% of 4 grams. So I'm going to take my 4 grams and I'm going to multiply it by the decimal number of this. So I'm going to multiply it by 0.3681. That's why I said you didn't have to do this multiply by 100 because we were going to divide it by 100 later. That's why we moved over the decimal. You can also divide it by 100 to get this number. So this is my 4 grams. I'm multiplying it by the percent to find the percent of oxygen in manganese dioxide. And my answer is 1.47. I need 3 sig figs, so I'll stop right there. Grams of oxygen. So there's my final answer. You're going to do all of the problems this exact same way. It is like a percent composition problem. You're just applying it to a mass. You should be able to sort of make number sense out of your answer. And so when I say number sense, like it should be able to make sense. For example, if you got like 4.25 grams of oxygen, well, in the whole compound there was only 4 grams, so obviously that's the wrong answer. Your answer has to be less than 4, and then you can come back up here and you can compare these masses, right? I can say that 54 is almost double of 32, like a little less than half. So what is half of 4? Half of 4 is 2, therefore 1.5 makes sense, since you know they're almost close to half, I guess, put it that way. It's almost close to half and half. So exactly half would be 2, so 1.47 does make sense. So you can kind of check it at the end by just checking to make sure your answer makes sense. We call it number sense. The other question I was asked about was number 8. So it says the minerals macrolite and chalcopyrite, I don't know how to say that, can be mined to obtain copper metal. How much copper would be obtained from 1 times 10 to the third, so 1,000 kilograms of each? So it's asking us basically how much copper is in each of those, given the given quantities. So this is actually kind of just like the problem we just did. So I'm going to go ahead and do each of them separately. I'm going to start with my copper hydroxide carbonate. Okay, I'm going to start with that compound first and do the percent composition just for copper. So my copper, and I need to multiply that by 2. I have oxygen. Oxygen's going to get multiplied by, I have 2 oxygen there and I have 3 there. So that's a total of 5 oxygens. Hydrogen is 2 because this 2 distributes to everything inside the parentheses. That's why I had 2 oxygen. Now I have 2 hydrogen. And I'm also going to need, let me see if I can move this periodic table down a little. There we go. Now, what was the last one? Carbon. We haven't done carbon yet. So carbon, and I just have 1 carbon. Okay, so I'm going to look up those masses. Copper is, what does that say, 52.00. Again, yours probably says something different. That's okay. It means that our answers are going to be a tiny bit different, and that is okay. Oxygen on this one is 16.00. Hydrogen says 1.008. And carbon on this one says 12.01. Okay, so I'm going to multiply this by 2, this by 5, this by 2, and this by 1. And then I'm going to add those all together. So for copper, that is 104.00. For oxygen, that's 80.00. For hydrogen, that's 2.016. And for copper, that stays the same because we're just multiplying by 1. Okay, so now I'm going to take all of those and add them up to get my total. And my total is 198.026. I realize that adding rules makes us not use 3 decimal places there, but since all those came from a periodic table, I'm just going to keep as many as I can decimal points, since, you know, those numbers are numbers I looked up. So now, again, I need to find just the percent of copper. So to find my percent of copper, I'm going to take my mass of copper, the 104.00, divide it by the total. And I get 0.525. How many sig figs? I'm going to need 3, so I'm going to just keep 4. That way I can round it to 3 at the end. Okay, so if I multiplied that by 100, that would be the percent. But I actually am trying to find the mass of copper, right? In the end, I'm trying to find the mass of copper. Actually, that's not what I want to write. Mass of copper is, then I can take the mass that I was given for the entire compound, the 1 times 10 to the 3rd, and I'm going to multiply that by the 0.5252. And for mass of copper, I get 525.2, but I need 3 sig figs, right? Because my given was 3 sig figs. So I need 3 sig figs, so I'm going to stop there. I'm not going to put in the 0.2 in the end. And this is in kilograms of copper. So now I'm going to perform that same thing for copper and the callow copper copyright one. I'm going to scroll down on here, so it's CuFeS2. Okay, so I'm going to perform all that sort of to make this video shorter. I'm just going to do it off screen and then I'll start again. All right, so I found my molar mass here for this compound here. Now I need to, again, do exactly what I did last time where I'm just finding the percent of copper. So I'm going to take the total copper, which is the, I'm going to do it over here. So, which is the 52.00. And I'm going to divide it by the total mass of the entire compound. And then again, you could multiply it by 100 to make it a percent, but since we're going to need to turn it into a decimal later in order to multiply it by the kilograms we were given, I'm just going to leave it like this. And when I divide that, I get 0.3023. Again, my answer is only going to need 3 sig figs, so I am going to just have 4 there. So now to find my mass of copper in this other compound, I'm going to take the mass I was given, which was the 1.00 times 10 to the 3rd kilograms, and I'm going to multiply that by the decimal of the percent that was in my compound. And when I multiply those together, I get 302. And then again, it's 0.3 in my calculator, or this is 1,000, right? So if you moved it over 3, you still get 0.3. But I need 3 sig figs, so I'm just going to stop there. The 3 does not round to the 2 up. It just keeps it the same. And there's my second answer. So I have my 2 masses, right? This was the mass from the first copper sample, and this was the mass from the second copper sample. And the question asked us how much copper could be obtained from each, so we just did that. And then it says, which of the 2 has the greater copper content? Well, this one here had 52.52%, and this one here had 30.23%. So which one has more copper? This one does. I hope that helps. Please let me know if you guys have any questions.